section on your screen, and Bob will pick those up at the end of Nigel's presentation. We will attempt to answer as many questions as we can during the allotted time, but I apologise if we don't get around to everyone. Also, I'll post in the chat line a link to an IET survey which we've asking participants to complete. So anyway, by a short introduction to Nigel. Nigel is Professor of Telecommunications at the University of Salford. He's an electronic engineer by profession who specialises in data communication networks and their applications. His research, which has a strong industrial involvement, covers 5G mobile, location and context-based services, communication protocols, the delivery of multimedia services, network design and architectures. He also takes a keen interest in telecommunications heritage and maintains an active outreach portfolio which includes the delivery of public talks and appearances in the media such as the BBC TV, Time Shift, Dial B for Britain. In addition to writing academic research papers, Nigel has also co-authored 2 books, 30 Years of Mobile Phones in the UK and The British Phone Box. Nigel is a chartered engineer and a chartered IT professional, a fellow of the Institute of Engineering and Technology, British Computer Society and the Institute of Telecoms Professionals. So I'll now hand you over to Nigel. Okay, you have the screen now, Nigel.
Right, well, thank you very much indeed, John, and thank you for the invitation to present this talk to you tonight, which is in essence an overview of the Internet of Things. So I'm going to turn my video off whilst I share my screen and put the slide pack up. So I'll just do that now. I hope that is visible to everyone. So good evening, everyone. Thank you for the invitation to talk. Today, as I said, the Internet of Things. Always useful to start with some form of definition, and I like this description from Ericsson: everything connected everywhere. And the important point here is that the Internet of Things is not separate from the Internet. It's very much an evolution of it. It's an expansion of it. And as you will see from the use cases that I'm going to highlight, it's really, and Ericsson say here, no limits except your imagination. So I want to have a look at the impact that the Internet of Things is having on us as individuals, in our home lives, in business, in the urban environment, in healthcare, and 1 or 2 others as well. Obviously, I won't choose every single use case that is out there, but hopefully the ones I have chosen are illustrative of the wider picture. But let's just start with a little bit of a history talk and go back to 1969 when the internet was born. And of course, computers in those days were the size of buildings and rooms, as illustrated here. But very importantly, and this is why I say the birth of the internet, was of course that in America, the ARPA network project in December 1969 achieved its first major milestone of connecting 4 mainframes together. And such was the power of those mainframes that they decided that a mainframe computer of its day was not capable of actually doing its own job plus that of communications. And so separate nodes or separate message processor units, which were mini computers themselves, actually had to be used as the interconnect. And they're represented by the circles on this truly back of the envelope sketch of those first four nodes that were connected. The rectangles are the mainframes and the circles are the communications message processors forming the interconnect. There is a direct line from the ARPANET to the modern day internet. So that's why I claim that this was a picture of its actual birth. 20 years later, it was Sir Tim Berners-Lee who wrote his famous paper, Information Management and Proposal, which actually set out the blueprint for what became the World Wide Web. And that really transformed the internet in terms of its usage or its usability, because until 1989, the people using the internet were really researchers in universities, researchers in industry, very large corporations. It wasn't by any stretch of the imagination the general public. But what the web did was suddenly use the internet as a means for accessing information. And the World Wide Web transformed connectivity in terms of the population connected to the internet, and really took the internet from being a tool used by a few specialists to something which the wider population could use. And if you look at graphs of take-up of internet connectivity and usage, you look at early 90s and suddenly it takes off like a rocket. Up until that point, very little in terms of percentage of population were using the internet. The Nokia 7110 was an innovative phone, a mobile phone which included for the first time an integrated web browser. It was marketed as providing the internet or the web in your pocket, because it used a web browser that used a protocol called the Wireless Application Protocol, or WAP. And unfortunately, the marketing was way beyond the experience that users actually gained from this device. So sadly, it wasn't anything like the web in your pocket, but nevertheless, it was the start of creation of the mobile internet, the integration of the internet and the web to the mobile phone. But of course, it was Web 2, the development of all of the social media that really, again, turned the internet into something different. It was very much a case that you used the internet and the web to consume content. You went and looked at a web page and you read it and accessed the information. Web 2 turned that on its head and allowed people to become contributors of information. And so the internet now becomes truly an internet of people, and the whole social media applications take off at this point. So what you're seeing here is how the internet starts as a means of interconnecting large mainframe computers. The web then allows it to be a source of information, static information in the main to start with. The mobile is providing another route to connect. And then, of course, we've got the social media and internet too, which is really transforming the content and how we share it and access it. So where does the IoT, or the Internet of Things, fit in to all of this? Well, there are lots of arguments about when it was born, but I'm going with the work of Cisco and the Cisco Internet Business Solutions Group, who actually come up with a fairly simple measure, really. And they've said, well, let's work out when in time there were more things or objects connected to the internet than people on the planet, than the global population. And this little infographic from Cisco shows that if you work on that definition, and yes, there are others, that the birth of what we call the Internet of Things was somewhere between 2008 and 2009. And you can see also that they're predicting here that as of the end of last year, whether this COVID has actually impacted these numbers, because these were estimates, of course, there would have been 50 billion devices or things connected to the internet versus a global population of 7.6 billion. That's not 7.6 billion connected to the internet. That's 7.6 billion people living. Actually, internet usage or connectivity as a percentage of population has only recently, the last year or so, gone over 50%. So if you worked it as a measure of the number of internet users, then the IoT would have been born a little earlier than indicated here. So let's have a look at some use cases of how the Internet of Things is being realized. And let's start with our familiar surroundings where we are at the moment, needless to say, in our homes. And I dare say that several of you are using what is called a smart thermostat. These are the 4 top leading brands in the UK at the moment: the Hive active heating system, the Nest learning thermostat, the Tado smart thermostat, and the Honeywell Evo Home system. There are others. These are the market leaders, the top 4. And what this is effectively providing integration of services in the home, mainly your central heating system. So let's have a look at just one of these. Let's look at Hive. And what does this comprise? Well, you've obviously got your gas boiler, and you've got your broadband internet hub. So the Hive receiver, excuse me, which connects to the internet, the boiler receiver connects to the hub and connects to a wireless thermostat. The wireless thermostat also connecting to the broadband hub. So what this means is that we've now got a direct connection between your central heating system, the thermostat, and the internet, for you to access that using a device in your home, which is connected to the internet, or more likely a mobile device away from your home. So if you have decided that you're delayed on the way home, you can alter the temperature of the thermostat. You can change when the central heating comes on. If you've gone away for the weekend, remember those days when you could go away for the weekend? Well, we're not doing that at the moment. But when you could, then if you suddenly realized there was going to be a drop in temperature and you hadn't left the central heating on, you could, of course, program it to come on remotely. But a mobile phone also has the added advantage of being a GPS receiver. So actually the apps which you have available are also capable of being programmed such that the proximity of you, i.e. your smartphone, to your home is also a trigger to automatically turn on the central heating, or indeed turn it off as you leave the property. So what's happening here is we've got the boiler is becoming a thing because it's now connected to the internet. The thermostat is becoming a thing because it too is connected and accessible through the internet. But of course, it doesn't just stop there. You're able to expand this system much further and connect electric plugs. There are receivers which you have here that will sit between the electric socket on the wall and the device, and those are programmable as well to switch on and off. You can turn the lighting on and off. There are sensors around the home as far as your burglar alarm's concerned, or indeed these video doorbells, which you can now get all fully integrated here. All of these devices become things which are now accessible, connected to the internet. So this would be the Internet of Things in your own home. And there are many other examples. Your television increasingly now is automatically connected to the Wi-Fi in your home and onto the internet because you're watching streaming services, Netflix, Amazon Prime, all of the catch-up hubs, ITV Hub, BBC, iPlayer, Channel 4, all have got an internet presence now. That shift to watching television through the internet rather than the aerial on your roof. But of course, the devices which also associated with the television, such as the recorders, are also now connected to the internet and therefore accessible remotely if you wish to program them. There's a growth in what's called second screen, whereby you could be watching the television program normally on the television, but you might be using your tablet to provide a second channel of communication for that program, adding additional information to the thing that you're watching. So devices are increasingly connected to the internet and to each other. I dare say an awful lot of you, the 22% of UK households, have got one of these voice-controlled digital home assistants. I will refrain from saying the name, because if you have one in the room and I do say the name, it'll probably get triggered. But here are two of the leading brands that from Google and from Amazon, the so-called smart speakers, which also, of course, provide an interface to all of the other devices which you have in the home. And I was interested in the little cartoon that was used at the start of the talk, whilst people were assembling. And there was a picture there of a fridge, wasn't there? And the fridge was saying to the person, "I told you to call in and buy milk on the way home." Well, here is genuinely a smart fridge, an internet connected fridge, and it's a real product. It's a Samsung smart fridge freezer, and I have checked, and currently available on the John Lewis website at £2,699. Fully internet connected. It has a camera inside it so that you can, should you wish, check on the contents of the fridge remotely through that camera. It does obviously have a light inside, and this is once and for all a technology which will prove that unanswered question that has eluded so many people over the years, and that is, when you actually close that fridge door, does the light really go out? Well, with this fridge you can find out, because that camera inside it allows you to see. Ernst Young produced this interesting report in 2019 called Taking New Steps into the Smart Home. And it was a survey to ask UK households what their most wanted smart home device was for 5 years. So that would be 2019, looking forward to 2024. Top there was the digital home assistant, the smart speaker, then smart lighting, smart security, got that the wrong way around. The digital home assistant, the smart heating system, then the security, then the lighting, the video doorbell, smart watches, connected cars, and then right down at the bottom of the list at 17%, so it's still a reasonable amount, a smart oven, an internet connected oven. So it's this report, by the way, from Ernst & Young's freely available for a download from their website, Taking New Steps into the Smart Home. Just look at the range of technology which is available for our connected and smart homes already. And all of these devices would be regarded as a thing connected to the internet, hence Internet of Things. What about healthcare? Huge market and huge potential for Internet of Things applications. Some really interesting work going on as part of the 5G testbed in Liverpool. And they've come up with a range of test cases and use cases to evaluate how the technology can help society, particularly with the health and social care agenda. So links directly to a pharmacy assistant that will allow patients or people at home who have medication to take. These are effectively pharmacist assistants which remind people that it's time to take their medication with a live video link, so that they are actually seeing a person and reminding them that you need to take whatever medication you need to take at this point. A really important one, safe house sensors. this is monitoring people at home, particularly elderly people or people with disability, looking for any indication that they've had a fall, or possibly that they haven't moved, that somebody has been in the lounge and sat in a chair for several hours and hasn't moved. That's an indicator, that's a trigger, as well as somebody actually falling over. So there's a large range of red button type services already available, but these are more than that. These are intelligently sensing individuals so that they auto trigger an alarm or an intervention. And very much so in COVID, I think one of the big impacts of COVID has been mental health and loneliness that people have felt being locked in their homes. Well, as part of the Liverpool 5G testbed, they've got this digital loneliness device with a push to talk, which is really there just to keep people in touch and to allow them to chat. It's the equivalent of somebody popping in on the way past. They've also developed more of a social dimension to this with quizzes and games for people who feel isolated. So looking at the technology that even post-COVID, so this will be hugely valuable. And the elderly care, keeping them in their own homes, is a massive area that requires technology solutions. Diabetes, again, huge impact on healthcare. And this project by Vodafone and Diabetes Care, a global project here. These are effectively internet connected via mobile phones, diabetes blood sugar testers, which provide data direct from the person into qualified medical practitioners who can then provide guidance and help to that individual. So this is connecting the sugar level testers to the internet so that that data could be made available to the medical people who can then offer an intervention where that is required. And of course, the first responders, the paramedics, this test with University Hospitals Birmingham and BT claimed was the UK's first 5G connected ambulance. And the advantage of the 5G connection here was the fact that they could produce a high data rate connection to the ambulance, which allowed not only video transmission, but also large volume data from any kind of monitoring equipment that they might put on a patient in an ambulance. And of course, it provides direct connectivity from the paramedic back to the hospital, whether that is because the patient is en route or they want an advice prior to bringing a patient into the hospital. So this integration of technology and sensors and networking in a medical profession here, again, another very good use case. The ambulance then also becomes a thing connected to the internet. Our cars, very much connected. The phrase now is connected and autonomous vehicles, CAVs, and there's a range of connectivity options that are considered. Vehicle to infrastructure, infrastructure being the roadside, vehicle to vehicle, vehicle to pedestrian, vehicle to the cloud, and vehicle to everything, which is obviously the catch-all. But the fact that vehicles are able to interact with each other, the fact that vehicles can report data, diagnostic data to the cloud for interpretation and processing for preventive maintenance or anything of that type. So the interconnection of the vehicle to the rest of the world, the vehicle becomes a thing in the broader Internet of Things. The kind of forecasts that you see for the automotive industry, the applications are well known in one sense. Infotainment, that's basically access to obviously entertainment services in the vehicle, not necessarily for the driver, of course. Remember, the passengers also want connection. Telematics, monitoring the vehicle, reporting diagnostic data, navigation, of course, improved navigation, with better integration with the environment, would give you the opportunity to be redirected, or indeed in an urban environment, possibly even managed in a way that you would in a smart city, perhaps divert traffic for reasons other than congestion, perhaps even air pollution reasons. And what I think is very interesting about this particular infographic is the logos across the bottom, because there's only one logo there, which is a car manufacturer. The others are all computer and communications companies and electronics companies. And talking to the automotive industry with a university hat on, the automotive industry does find it difficult to recruit young engineers graduating from universities in subjects like computer science, cybersecurity, networking, and electronics, because this industry is traditionally not seen as what they would go into. Well, it very much is, because those are precisely the skills the automotive industry is now seeking. O2 are doing a lot of work on 5G and connected vehicles, and they've created the connected and autonomous vehicle test center, test bed, which is called their Smart Mobility Living Lab. It's not just about self-driving vehicles, of course. The fact that the vehicle in front suddenly brakes, if that signal is sent back to your vehicle, then your own braking system can react quicker than you could react as the driver. So the fact that the vehicles are all able, as you can see in this graphic, to effectively sense each other around them, then that will aid road safety and hopefully also prevent some of the congestion blocking that you get. So that hopefully means that traffic flows more freely as well. We've got our own autonomous vehicle at the University of Salford. It's a Navier autonomous vehicle. It's a shuttle. It takes about 8 people. And this drives around our campus. It's not road legal. One of the biggest challenges you have when you try and register this vehicle on the road is you can't answer the first question, because the first question is it left or right-hand drive? This vehicle doesn't have a steering wheel inside it. So you can't answer that first question. It basically is geo-tracked, so you train it on a route, and it uses GPS with a local beacon to provide more accuracy, so that it follows a pre-programmed path. If anything blocks that path, then it's got an array of sensors around it, and so would automatically stop. The next level, of course, would be the avoidance and the moving around objects, and that's obviously a further development. So it's early days, but it's quite interesting to see this technology emerging. And I found this little case study quite fascinating, because forget the vehicles, let's talk about something else, car parking. And Milton Keynes, and again, I find this number quite surprising, but they said, Milton Keynes Council said it costs approximately £15,000 to create a new parking space. And the problem with Milton Keynes that they identified was that people complained about not being able to park. Yet, according to their data, at any one time, there was something like 7,000 car park spaces empty. Yet drivers were still complaining that there weren't any car parking spaces. There were lots, they just couldn't find them. So how do you address that problem? Well, here comes the Internet of Things. On the bottom left diagram, there's a red arrow pointing down at a disk in the car parking bay. That disk is a device which senses the fact there's a vehicle over it or not. That device is battery powered. It has a communications module in it and is able to indicate its status to a receiver on the roadside. So if a vehicle was to park in that space, then obviously the communication link would be lost, and that space would be registered as occupied. You start integrating that data across the city, combine it with a mapping tool, and all of a sudden you have a live map of every car park space in Milton Keynes in its current occupancy. And you can then program the sat-nav applications to direct you to a vacant car park space. So you aggregate this data from all of these sensors into a central processing point, and you can then provide much more accurate and real-time data for drivers who want to park in Milton Keynes. Ongoing project, Milton Keynes Council and BT, but a classic example of Internet of Things in action. Agriculture is another huge use case for the Internet of Things. The United Nations Food and Agriculture Organization have identified that we'll have a global need to produce 70% more food by 2050. But here's the catch. There's going to be no more land. So it's going to be very much a case of having to produce more from less, because in one sense, the amount of farm land is declining globally, not increasing. And the planet isn't going to change size, even if the population does. So agriculture, farming have got a huge challenge going forward. And here again, the Internet of Things is coming in to play. We now talk about precision agriculture, or simply smart farming, using IoT technology, really trying to make optimum use of the resources that we've got in order to increase crop yields, yet at the same time minimizing environmental impacts. So we are talking here about sensors in the ground. We're talking about weather stations monitoring current climatic conditions. We are indeed talking about self-driving autonomous farm vehicles, tractors, etc., and also drones being used to aid farming. You collect all of that data and you start processing it, then what you're able to do is better manage your environment, your farming environment, to improve yields and to optimize when you would water, optimize when you would feed, and so on. Now, of course, this is an infographic. It shows you what's possible. These products are real. Most of these are Eastern Peak products. So we've got the weather station monitors connected to the internet so that you can see precisely the conditions in a field. The crop management sensor there is detecting moisture levels and also nutrient levels in the soil. The cow actually has a collar around it. That cow is also being tracked, and you can put life signs monitors on that so that you can check the health of the cow, but also you can do something called geofencing of livestock. That is, you can be monitoring the location of an animal, and you can create a virtual fence that is a set of coordinates. And if the animal crosses those coordinates, you get an alarm because obviously it's GPS tracked. And then drones used for very accurate monitoring and also spraying of crops with nutrients and so on. So all of this technology now being employed into the farming agriculture industry. All of these things then also would become things connected to the Internet of Things. And logistics. If you can do better tracking of products in transit around the world, then you're much better with predictive delivery. You've got a much better handle on your inventory tracking and your location management. Security, of course, if you know where your objects are, it's a bit like the geofencing of the cows and the animals. It's just as important to know it isn't where it should be, so that would indicate that something untoward is happening. And of course, the more data and analysis you've got, Then from a business point of view, the whole operations of that business, stock flow in and out of the business is so much better managed and able to be maximized for the organization. Belfast Harbour has become the UK's first, UK and Ireland's first private 5G network. What does this actually mean? Well, 5G, the latest generation of cellular network, a private network is one which actually operates, in this case, only within the port. There are now licensed frequencies available outside of the cellular commercial bands for deploying 5G networks. So you get a full 5G network, but of course it's only for, in this case, Belfast Harbour. It's not for a replacement of Vodafone or whatever services that you and I are using. So private 5G is a 5G network. It's private in that it's restricted to these particular operator, this operator being Belfast Harbour. And this has just been announced last October. And really what they're doing here is connecting the all aspects of the port and its operations together, including the connected autonomous vehicles that are in the port. Monitoring people for lone worker health and safety is an important factor in this type of environment, as well as supply chain and logistics tracking and better tracking of containers and other items of cargo in and out of this port. So Belfast Harbour there is the UK's first fully 5G private port. So again, logistics, transportation, integration of data, integration of devices, analysing that data, using it to improve the efficiency of the organisation and the operation. And while we're talking about 5G, 5G at the moment is really seen as something which the smartphone user will have, that is you and I. And the headline figure is the greatly improved download speeds that 5G offers. All true, and we call that enhanced mobile broadband. And that is the top of this triangle here, taken from the standards of 5G. However, triangle's got 3 points, and what are the other two? Well, bottom left is massive machine type communications, and the right, ultra reliable and low latency. The 5G story is therefore far more than smartphones and increased download speeds. 5G is very much about things connected together. So massive machine type communication. They're talking about a capability to handle 1 million connected devices within a kilometre square. Ultra reliable and low latency, absolutely essential for real-time data collection. And if you've got a connected vehicle interacting with a roadside infrastructure or indeed an adjacent vehicle, you want ultra reliable, you want low latency communications, and that is very much driven by what 5G is trying to deliver. So if you look at the examples there, smart city is clearly a massive machine type application. Self-driving vehicles, connected autonomous vehicles, again, ultra reliable communications. The enhanced mobile broadband is about gigabytes in a second, but most Internet of Things applications don't need large volume data. They are sensor data. Generally, they need low latency, ultra reliable, but they're not demandant of bandwidth. Another way of looking at 5G use cases, of course, is the ultra reliable low latency across the bottom there, vehicle to vehicle, vehicle to pedestrian, and industrial automation, massive scale communications across the middle. Again, you've got social networking, you've got healthcare monitoring, smart homes, smart cities, vehicle to infrastructure, and again, industrial automation. So the extreme mobile broadband is where you've got high bandwidth applications. So that would be where you're truly doing a lot of video monitoring, for example, or indeed you're wanting to do virtual reality or augmented reality type applications to a device. So there's an awful lot more to 5G that we haven't seen yet. And most of that is to do with the Internet of Things. But there are other technologies for connecting devices together. That ship at sea with its cargo containers is going to get no benefit whatsoever from 5G. So low throughput networks such as Sigfox here, providing low frequency, longer range communication, but very low data rate. Because if you think about a container on a ship or indeed in transit, all you need to know is its location every so often. It's not a high data throughput requirement. It's low volume data, long range, low power, and that's exactly what technologies like Sigfox are intended to deliver. So you've got your objects on the left interfacing to Sigfox base stations or gateways with a radio frequency at about 200 kilohertz. That data is then aggregated through the cloud into your business application that you're running. So low volume data is what matters there, and low power wide area networks, of which there are three basic variants, LoRa, narrowband IoT, and LTE mobile, are again examples of this sort of technology. Lower frequency, lower data rate, but it's designed for connecting devices. Your thermostat in your home, or indeed an environmental monitor in the street of your city, doesn't have high volume data requirement. The temperature is not going to change that rapidly, and it's basically a very small amount of data bits to tell you what the value of the temperature is. So all of these different technologies, these other radio networks, are there to facilitate the integration of devices into the IoT. The market share of these shown here from IoT Analytics, you can see that effectively it's LoRa and narrowband IoT that are dominating, and that's expected to remain pretty well the same going forward into 2025. Sigfox generating a little bit more market share, but fundamentally LoRa, narrowband IoT are the two dominant low power wide area network connection technologies that are going to drive the Internet of Things. There are other methods of connecting devices, of course, as this particular graphic shows. The low power wide area network is actually very close to the top of this diagram. The broad orange at the bottom is wireless personal area networks, followed by wireless local area networks, and then cellular. The technologies we just talked about are all in addition to Wi-Fi and cellular. Of course, you've always got the option of wired connection, and 5G will start to take its share of connections in the IoT as well. So connectivity is absolutely essential for these devices, and the vast majority of that connectivity will be wireless. Applications to industry are also huge, and we talk about the industrial Internet of Things, where essentially in the industrial environment, the manufacturing environment, you now have a network of sensors connected wirelessly, often with a private 5G network in the factory. That data coming into a central collection, a cloud type service. And once you can analyze your data in one place, you can start then generating new insights into the manufacturing operation. So with better asset management and predictive maintenance, you can reduce costs, shorter time to market because you can reduce product cycle time. Real-time data tracking gives you better inventory management. Device level data allows you to make better use of its energy consumption and thereby improve the energy efficiency of the whole manufacturing plant. And monitoring devices and pairing that with wearable devices on staff also helps improve health and safety, particular things to do with lone workers. The UK government in 2017 established the Made Smarter initiative. It was chaired by Professor Jürgen Mayer of Siemens, and this has now moved on to the Made Smarter initiative, which is very much about encouraging UK industry to adopt Internet of Things. So as it says here, the UK is set to be the global leader in the creation, adoption and exploitation of advanced digital technologies. Now's the time for manufacturing to evolve, and with emerging technologies, the possibilities are endless. There's a huge Internet of Things agenda within the Made Smarter initiative of the UK government. And just to show that this thing is real, Nokia with the Oululu factory in Finland, this is a test case for the smart factory. They have deployed industrial IoT. They say they've demonstrated productivity gains of 30%. There's been a 50% saving in time of product delivery to market. They used a pre-5G technology for this particular plant. They've got autonomous vehicles moving around, all connected through a private cellular network. Production testers and sensors are all integrated. And of course, the benefit of wireless is you don't have to cable the factory up. You can move devices around. Therefore, the costs of implementation are a lot less, and you've got a lot more flexibility to reconfigure production lines. That data collected with cloud-based analytics gives you a far better control and monitoring of the environment. And just to put a UK perspective on this, in January this year in Birmingham, AE Aerospace was declared as the UK's first small-medium enterprise to deploy a private 5G network in their West Midlands factory as part of the West Midlands 5G initiative. So what have they got? They've got IoT machine sensors, giving them high volume data capture, production flows, machine time utilization, asset location, calibration tracking, and quality assurance, obviously spotting damaged components or indeed avoiding damage in the first place. So AE Aerospace in Birmingham is seen as a test case of the smart factories private 5G in the UK. Our cities themselves are getting smart, and the IoT is playing its part. Around this infographic, the writing is too small to read, but that's not the point I want to make. I just want to make the point that there are so many opportunities. Each of the boxes around the outside of this graphic is an opportunity to deploy technology and exploit it for fire safety, greener buildings, air pollution control, smart grid, real-time monitoring of traffic for congestion avoidance, journey time reduction. You've got monitoring of waste. You've got the public transport infrastructure, smart street lighting, where you effectively turn the lights off if there's genuinely no one who needs them, no vehicles, no pedestrians on a street. Turn the lights off, turn them back on again when somebody appears. Huge opportunities in the urban environment. And believe it or not, there is a smart city index. These organizations produce a league table every year of global cities who are achieving smart city status through the deployment of technology. And the latest league table puts Singapore at the top, quickly followed by Helsinki, Zurich and Auckland. Going down the list, the first time UK appears on here as number 15 is London. And I was actually pleasantly surprised that new entrant at number 17 is good old Manchester. So all of the cities around the world are certainly looking to how they can adopt technology to improve the operation management of the city. And if I just focus on Amsterdam, number 9 there, it's gone up 2 places, but Amsterdam has been leading the way. It's been a test case for Europe for a long time, and is making real progress in terms of what it's doing. So just to focus a little bit on Amsterdam Smart City, the website there for more information, really embraced the idea of the Internet of Things in the city to try and look at various benefits. The Amsterdam Economic Board that oversees the project has created city data. They've basically created a massive data set, open source data of the city. You can contribute to it. You can use it completely freely. If you want to develop an app that uses this data, the data is made available completely free for you to do that, to facilitate innovation and the development of ideas. This was a core thing of the Amsterdam Smart City Initiative. Make the data available, let people innovate. Climate Street was an initiative there. They deployed smart street lighting and other technology, and that particular area of Amsterdam saw a 10% reduction in its energy consumption. Citizen was a smart energy grid. This is smart meters in homes. This is solar panels on buildings, but all integrated into a single control network. And they say that the lifetime of the project, over 59,000 metric tons of carbon dioxide was saved because of better energy management. We all know that Amsterdam and Holland is littered with canals, and no doubt not be too surprised to know that that has been an important feature. LoRa network of connected sensors monitoring water quality in canals and water flow as well. A nice development that's in progress at the moment is they're going to start trialing autonomous canal boats as water taxis in Amsterdam. They've done some trials of some models. They've now got full-size ones, which they're about to start a test of in Amsterdam, to try and cut down traffic on the roads, make better use of the canals with water taxis, which are autonomous vehicles. And it was mentioned at the beginning, I've written a book about phone boxes, so I always like to get a phone box in somewhere in a talk. And here are the 2 latest generations. You've got the Newell payphones Amscreen phone box on the left, and you've got BT's Lynx kiosk on the right. Notice they've all got these digital display screens on them. They're all connected devices. And all of a sudden, this display screen, which would normally be carrying an advert, which is, needless to say, the way that you can afford to put this infrastructure on the street and make it commercially viable nowadays. However, that is a display screen. And if needs be, that can be immediately turned into a public information center, as it has been done throughout COVID. This picture in the middle is a BT Lynx kiosk, and you notice immediately the screen is now showing NHS a COVID alert, and this was taken in Leicester. Remember, they were one of the first early ones to go into another city type lockdown. So suddenly the infrastructure becomes public information points, and if you can control it remotely, you can do all sorts of interesting things. So what are the main use cases? Well, connected public transport, traffic monitoring, water levels, flooding, connected street lights, fire, emergency detection, protection. These are classic top 10 smart city use cases as identified by IoT Analytics. But the IoT ecosystem is all about, in one end, the sensors and the actuators that are effectively at the coalface of the application. Then you've got the networks that interconnect those devices and allow the data to be transferred, often into a cloud storage point where you do the data processing, where you collate the data, you manipulate it, you validate it, you have your algorithms for processing it. That can then lead off to a data visualization platform, or of course onwards to the main application, the action area, which is where you've got the feedback, the control, the artificial intelligence that makes this whole thing work. So the sensors and the actuators and the networks, they're just the first step. The real intelligence and value add of these applications comes from the data processing, the data visualization, and the actions that then result from that increased knowledge. There's no point collecting the data if you can't process it and analyze it. And collecting that data is increasingly a challenge, because that's the challenge of big data, which analytics company IDC reckons by 2025, IoT connected devices will be generating something in the order of 79.4 zettabytes of data annually, a zettabyte being 10 to the 21 bytes. This is huge volumes of data, and it's all got to be processed efficiently. And that's why artificial intelligence is such an important part of the IoT, because there's no other way of processing and analyzing this volume of data that the IoT is going to generate. And if we can't analyze it and process it, it has no value. So absolutely hand in glove with the sensors and the networks is the data processing, the visualization, and all of the artificial intelligence. Are there any challenges? Well, of course there are. And this survey was of businesses to say, what is restricting you from implementing IoT or adopting IoT? And as you can see, costs of implementation was seen as a major barrier. Security, needless to say, is significant. Upfront costs of buying the equipment required to implement an IoT service. Its scalability, how are you able to cope with massive increases of data, or indeed the need to roll out your technology to a greater number of devices. The whole corporate buy-in, because if you don't integrate this into the business, then is there really going to be any true value? And of course, the ongoing maintenance costs of it. So take the Milton Keynes car park example. You've now got thousands of sensors in the tarmac, each with a battery in them, and they're going to have to be replaced. So there's upkeep costs and maintenance issues of all of these types of applications. And talking about security, of course, what you've done with the Internet of Things is created millions and billions of devices, each of which are potentially connected to the internet, each of which is potentially a backdoor into the internet. And if you think about a lot of these sensors, they're very low power devices, that's processing power as well as energy. And that often means that they're not easy to install sophisticated security protocols on them, because you haven't got that processor capability in the device to put the application. And therefore, that becomes a security weakness. So the whole issue of cybersecurity of the Internet of Things is massive. And obviously, changing the function of a device is a great concern. And people use the example of the connected kettle. You know, people say, why would you want to connect a kettle to the internet? Well, just imagine if you did, what would be the security implication? Somebody could boil your kettle in your home. Is that really such a threat? Well, no, but if you suddenly switched on 10,000 kettles in an area, the energy demand on the grid would be very noticeable. So by manipulating thousands of devices, you can have that ripple effect, which then can have very measurable impact elsewhere in the supply chain. The whole idea that you've now got the ability to remote control your house is a security threat to someone with malicious intent, or indeed just capturing the data itself and analyzing that data can tell you about home occupancy, can tell you about lots of other things, which becomes a security issue. And as I said earlier, the device is an entry point into the network, and from there to lots of other applications. So there are, of course, there are huge security threats to the IoT, but the industry is working very hard on all of those areas. Always a bit wary of hard and fast numbers on market sizes and predictions particularly. But what I think is useful with this particular slide, which is showing the European market for the IoT by country in millions of euros, the dark blue is 2020, the light blue is 2014. And what I think is most significant about this analysis is not the headline numbers, just the difference and the sheer growth over those 6 years of the potential IoT market. So it's this opportunity that I think the slide gives us and shows us, not getting hung up on the individual numbers there, but there's clearly huge growth and rapid growth over the last few years. And going back to IoT analytics, this is also interesting analysis, because what this is showing is the number of devices, effectively device connections, which wouldn't all be considered as Internet of Things. So for example, your smartphone, your PC, your laptop, your tablet. What this graph is showing is the total number of devices connected and the percentage of those which are truly Internet of Things. So if we were to pick, shall we say, 2019, because that's a real figure, not an estimated figure, you're talking there about 20 billion connected devices, of which 10 were your smartphones, your PCs, your laptops, and those things, and 10 were the Internet of Things devices, your smart speakers, your thermostats, your environmental monitoring, your traffic light sensors. Look how that pattern changes. The number of devices, smartphones, etc., is not actually going to increase massively over the coming years, but the number of Internet of Things devices is potentially tripling over the next 5 years. So what this shows you is the significance of the Internet of Things as a percentage of the total connectivity market. And again, there's clearly huge growth there coming from the IoT. In addition, very much huge compared to the growth in things like people's smartphones and other electronic computer devices. And the major application areas, well, manufacturing, industrial, industry IoT, transportation, energy, retail, particularly transportation and logistics, smart cities, healthcare, and I think healthcare is going to grow much more than that over the next few years. Supply chain management, farming, agriculture, smart buildings, but a lot of that will be wrapped up in smart cities as well. So always conscious of the time, and our hour is just coming up now. The Internet of Things, it's a world where everything, potentially everything, is interconnected. And I hope by sharing with you today some of the use cases that are emerging, not theoretical, I've chosen real examples to show you that it is real, it is happening, and there is huge potential here, and clearly massive investment going in to the Internet of Things. So, as I say, always conscious of the clock and the amount of time we've got, and I know that there are probably some questions coming in, so I will stop there and just say thank you very much indeed for your attention. If you want to get in touch with me, I'm there on social media, website, and thank you for your attention, and hand back to the host. Thank you.
Thank you, Nigel. This is Bob Swindle from the Kendal Engineering Society. I'll try and go through most of the questions that we've had. Some of them are of the same subject. Can you hear me, Nigel? Are you unmuted?
I am now, yes.
Okay.
I'm just taking the slide share down.
Yes, that's fine. Yeah, okay. Put your video up and then they can see you answering the question. Okay. The very first question, which I thought was a very good one, from Mark Holmes. He's an electrical engineer of 30 years, and he's trying to keep up with things. And based on what you told him tonight, it's quite difficult because things are moving quite quick. Where's the best place for him to go and get some information and keep up to date, other than coming to your lectures?
well, the IET itself, of course. But organizations like IoT Analytics and others, IoT Journal, a lot of these web presences are really keeping us up to speed with industry trends. And you can see I've pulled a lot of data from those kinds of sources. I regard those as good, useful sources of what's going on. With regard to technology, then clearly the network companies like Nokia, Ericsson, and others are very active in this IoT space as well. So there's there's so much available now on the web with organisations like this. But of course, all of the professional bodies, and particularly the IET, are very much covering this area.
Okay. A question from David Downs. You do answer it later, but let's try and tease out what's the real difference between 5G and 4G?
Well, there are differences in the radio interface, the actual protocols that are used for communication over the radio, the frequency as well. That allows us to get more data rate through that connection. But as I said, that's just the one point of the three-pointed triangle. What you've also got in 5G is a different architecture. You've got a full 5G core network, which will mean that we've got latencies down towards the 10 millisecond range. You've got a lot less delay, which is important. But you've also got, with things like massive MIMO antennas, the ability to actually direct the radio communications almost like a spot beam to individual users. And this will not only allow greater connectivity in an area, which you need for multiple devices, but will also allow that connectivity to be more reliable in terms of being maintained. So there have been a lot of technological advances in the radio technologies, which have facilitated 5G. So it really is a technology that's designed for the very high bandwidth applications, so a lot more throughput and bandwidth than you get on 4G. A core network which is effectively designed to give low latency, and access technologies, radio antenna technologies, massive MIMO, which allows you to have that large range of devices connected. And that then allows you to actually differentiate the service that you deliver. It's called network slicing. So for example, you could have one user connected and be given a high bandwidth service, another person connected to the same point in the network, but they could have a low bandwidth, ultra reliable connection, low latency. That ability to differentiate the users and offer a different technical service called network slicing is another important part of the 5G ecosystem. A lot of this hasn't come through yet because it's been phased, rolled out. And the headline at the moment is the only one you've seen really is the high-speed download onto smartphones, but there's a lot more coming.
Yeah, just a question on 5G. The higher the bandwidth, the shorter the distance, it will travel. You end up with lots of small cells.
Correct.
And one of the big issues, even with the earlier 3G and 4G, was handover times, especially if the user is moving. Is this going to cause a problem on 5G?
No, the handover's now done at the edge rather than back through.
Oh, okay, it's not in the center anymore.
Okay. One of the biggest challenges, of course, you're quite right, it means a lot more base stations and small cells. They've all got to be backhauled into the bigger network. So deploying fiber and microwave backhaul connections is an equally important part of the 5G network. You're quite right, there will be a lot more base stations, a lot of them quite small, but if you want to get urban connectivity, you're going to have to do that. And they've all got to be then connected back to the bigger network and powered. Okay.
You mentioned the word fiber, so let me just develop from that. The more you put on the network, the more the bandwidth you need. And those of us with Wi-Fi at home, which goes at less than 3 megabits, would quite like, a slightly bigger connection up to the network. No, do you think I'm going to get fiber to the home in my lifetime?
Oh yes, yeah. You can, yeah. I mean, there's a huge investment in 5G fiber deployment to the home now. A lot of more new entrants coming in. People like City Fiber and others coming in to install fiber. Companies like OpenReach are investing in new technologies for the better installation of fiber. It's interesting because I chair the editorial board for the Institute of Telecoms Professionals Journal, and the issue that's just in the printers at the moment, we've got an article in there from OpenReach about fiber deployment, the civil engineering works actually, the new trenching tools, and even the ability to lay fiber without the need to dig a trench. So there's a huge investment going in for deployment of fiber. So yes, you will. I'm sure of it.
Oh yeah, I'll watch the share price in BT then. There's a question from Mark Graves, which is all about IPv6 or IP version 6.
Yeah.
The hype around that seems to have disappeared, he says. Where's it going?
Oh, it's still there and it's growing. It's slowly taking over. I said 5G is all IP version 6. If you look on your smartphone, you've almost certainly got an IPv6 IP address now. It's rolling out. It's doing it quietly in the background, and of course, it's coexisting with IP version 4. But we have to have IP version 6. It's absolutely essential. So it's quietly happening in the background. And it's slowly but surely gaining the percentage of connections now. The version 6 is definitely ramping up now.
Okay, there's quite a few questions around security and reliability, some of which you've covered, but let me pick up the one which was, I was one of the first early adapters of Hive.
Okay. To
say it was reliable and had a good user interface would be kind. And now they've fixed a lot of that, but where is the really serious testing being done for when you get to a level of deployment where you're almost mission critical on people's lives?
Well, I think the entire industry is working hard on this, and also the likes of GCHQ. There's a massive investment in security and critical infrastructure, because as soon as you go down the smart city route, then you are in that critical infrastructure world. We are going to be totally dependent on the networking, and it has to be reliable. And I don't just mean from a cybersecurity point of view, it has to be reliable against extreme weather, against power outage, and all of those things as well. So the whole protection is not just the cyber security side, it's also the physical side as well.
Yeah, I was more or less dealing with the reliability side, not the security side.
Yeah. Well, absolutely. So
mission critical networks are very difficult to design.
Of course they are. Absolutely are. And you're having to look all the time at duplication, triplication, backups, and so on. So, for example, the police emergency services network is moving away from Tetra to actually EE, mobile phone. And that company's had to invest huge amounts of additional infrastructure to guarantee the reliability of connection. Quite a big use of, for example, satellite backhaul as a backup to the cellular systems and so on. So to make an ultra reliable network is not easy, and it does require an awful lot of investment in infrastructure.
Okay, let's deal with the security one, not from the point of hacking, but my Alexa's far enough away from me to mention her name, but I know she's listening.
Yeah.
And there are all sorts of rumors that you're watching a TV program, you talk about something, and the next minute an advert appears because your TV has listened to you. I don't believe those, but where's the government regulation stopping Amazon basically tapping into every single smart speaker and listening to what's going on and then selling you something?
It's a good question. And I think you'll find that regulation and the whole legal framework is always lagging behind technology, because the technology is moving at such a huge pace. And inevitably people, the smart speaker has to listen all the time because it has to be there when you say the keyword. It's a bit like your smartphone has to be tracked by the cellular network provider because they don't know when somebody's going to try and send you a message, so they have to know where you are. So you have to do that if the service is going to be delivered. The real question is the storage and processing of that data. And I think you're right to highlight it as a regulatory issue, absolutely.
There's a question around, again, with the dependency, the more you have, the more power you need. And since some cities in parts of the world are having no power because it's being used for Bitcoin generation, where's the additional power going to come for all these things, other than from batteries in the road?
Well, again, another important area that, this is, I've concentrated on one aspect of the IoT here, the area that, communications area that I'm in, but inevitably there are lots of others here, including the energy producers and distribution chains, semiconductor manufacturers, device materials. It affects so many different aspects of industry. And so it is a collective in that sense. The telecoms industry's worked very hard to reduce its energy consumption. Devices are getting a lot more energy efficient, but of course that's counteracted by the fact there are now more of those devices. So the energy efficiency improves, but the number of devices going out goes up. Therefore, the net demand probably stays very similar. So generating power from renewable resources in the area of the sensors, such as solar panel cells and things like this, again, has to be part of the equation. And this is what Amsterdam I used as an example. Their smart grid was very much about using in the immediate locality local generators, that is people with solar panels on roofs, actually managing that energy in the local area for the local demand and not sapping it out of the national grid. That's what smart grids are about, that ability to actually almost micromanage the generation and consumption of electricity.
I think the national grid is worrying at the moment, never mind the actual distribution of the power. Where's the power going to come from? Question on the addressing arrangements on the IoTs. Does every IoT device have a MAC number? And if so, who controls allocation of them?
Not necessarily a MAC address, but it will have to have an identity and address, yes.
So who controls that?
Well, they don't all need to be globally unique in that sense. You only need them to be unique in the area of your gateway control, as it were, so long as you can identify them in that zone. So that's what's happening all the time with private IP addresses versus public. So you don't need every device to have a globally unique identity because you've got effectively a hierarchy of addressing to cope with that.
Yeah, I guess the question is who's allocating the addresses, irrespective of their segmentation.
Yeah, well, obviously MAC addresses come out of the IEEE as that example. The IP addresses are coming out of the IETF. With regard to things like LoRaWAN and so on, I'm not altogether sure, actually. Most of them will be kind of like a mobile phone type number. Yeah, I'm not altogether sure with something like LoRa and Sigfox, how they do the addressing of those. So that would have to be something you have to look up, actually.
Okay. David Downs wants to ask another question. You can choose to go down this rat hole as far as you like, but he wants to know about smart meters.
What about them?
They doesn't ask that bit. Do they work? Where's the new ones are going to come? Are they reliable? That'll probably start you off.
Well, I've got two here in my house, a gas one, an electric one. And
me too, yeah.
To be honest, I don't use them because I knew how much electricity and gas I was consuming anyway. But touch wood, so far, they haven't interrupted either the electricity or the gas supply to the house. So I've no evidence to say that they're not working. So personal experiences, they seem fine. But I have to say that in my particular case, they've not really changed my lifestyle.
No, me neither, actually. Yeah. A question about, are you involved in the ESN network? You might know what that is, I don't.
That's the Emergency Services Network, isn't it?
Oh, right, okay, I do know what it is.
And not personally, no. Not personally, I'm not. But I do work quite closely with a person in, well, they were in EE, the network architect of EE, now that they are the network architect for BT. And they are very heavily involved in that particular initiative. So not personally, but I do collaborate with a person who is on other projects, by the way, not on an ESN project.
A good question for you. What comes after the IoT?
Oh dear. I think we're too busy trying to make it work in the first place to think it will evolve like all of these things. And that's what I tried to start at the beginning. Do you think in 1969 they envisioned what we've got now? I doubt it. You know, some science fiction writers do hit nail on the head sometimes. But it evolves. When the internet was put together, there was a very good reason for doing it, and that was they wanted to get more people to use these very expensive mainframe computers. And so a network was seen as a way of doing that. You know, Tim Berners-Lee's motivation was really about sharing of scientific papers and documentation that was coming out of CERN when he created the World Wide Web. That was kind of one of the use cases they were trying to solve with the web and hypertext and hypermedia. And again, you know, who would have thought a lot of these applications that emerge, you can't have predicted them. And that again could be back to Amsterdam, their decision to go for open data, just make the data available, was deliberate to generate innovation. Because if you had a great idea for a mobile phone app, the data is there, the data sets are there, use them, see what happens. If it fails, it fails. If it's successful, great. And you just don't know what's going to come out of these innovations. And I'm certainly not going to try and predict anything because A, it'll be completely wrong. Because who knows? We just don't know.
Okay, I think there's a number of questions which we'll pick up. We'll let you have a look at them later and maybe you put an answer on the web. So looking at the time, I think I'll hand over to Suzanne and ask her to wrap up.
Okay.
Suzanne.